Hi everyone, my name is Dustin Bonakdar. I'm a math tutor and I have a YouTube channel. It's called Dustin's Fun Math, and I hope you have enjoyed my videos so far. And today we have another episode of Dustin's Fun Math with an interesting math problem related to integration. So let's get it started. We have an integration. One second. We have integration is a to 0, and then we have dx over a square root of a squared minus x squared is equal to integration of a to 0, and we have x uh, over a square root of a squared minus x squared. Then we have a dx here. The idea is, I'm just going to write it here, find the value of a. All right, that's what you want to find. So we have two sets of integrations. The left hand side, if you're going to use a technique called trig substitution, and the right hand side we have integration that we're going to use U-Substitution to solve it. So once we get the results from the two integrations, we equate the results together and we solve it for a. All right, so let's start with the left hand side integration. So my idea is to substitute x with a sine of theta, right? When we have a square root of a number to the power of 2 minus a variable to the power of 2, we use x equal a sine of theta substitution. So it depends on how the inside the square root is written. Then we define our x as either a sine of theta or a tangent of theta or a secant of theta. In our case right here is going to be x equal a sine of theta. So let's see what happens if we do that. So first of all, we take the integration of dx to respect to d theta, and which is going to turn out to be a cosine of theta and d theta. And then let's see what happens to the square root. So if you substitute x with a sine of theta, we end up with a square sine square theta, right? And then if we take the a square, factor it out, we have a squared times 1 sine square of theta. And then this is going to be, in fact, be a square root of a squared. And based on the trig identities, this is the 1 minus sine squared theta is equal to cosine of a square of theta, which in fact, it comes out and becomes a cosine of theta. All right. So these are the process we did so far. And so yeah, let's substitute the results such as dx and the square root of a squared minus s squared with the equivalent of a cosine of theta. So what we have is going to be integration of a cosine of theta d theta, and then the square root of a squared minus s squared becomes a cosine of theta. And then these are simply the a cosine of theta with the other a cosine of theta in the denominator. They cancel out, and you end up basically with a very simple integration of d theta, which in turns to becomes theta. And we want, because our integration, if as you can see, the interval is between a to 0, so those are our x values. So we want to make sure our theta is expressed in x, so we can use the interval of x values of a and 0, right? So as we can see, the theta is actually equal to, so if we have a relationship from x equal a sine of theta, which sine of theta is going to be equal to x over a. And then we know that from inverse of trigonometry, the theta here is equal to arc sine of x over a, right? So our theta here, as you can see, is going to be equal to arc sine of x over a. All right, and yeah, so let's substitute the a and 0 in this case to see what happens here. um, I'm running out of a little bit of a space here, so let me get rid of some of the process we did here. So we open up some space. All right. All right. Okay. So we have gonna write it with red. So I have arc sine of x over a, and the interval is a to 0, right? We are evaluating the left hand side of the integration, and we integrating the left integral, which we did, and the result is going to be finding the interval between a to 0 with substituting a and 0 for the x. So this means we have arc of sine of a over a, right? And then minus arc sine of 0 divided by a. So in this case, the first one is just simply arc sine of 1, right? And the second one is arc sine of 0. So there is something very interesting about this one. So the arc sine of 1 is just pi over 2, right? That is there's no other answer to that. But for arc sine of 0, we know what makes 0 is going to be the angles of 0 itself and pi and 2 pi. So basically you're going to have three set of different solutions. But since we want to just focus on one solution, let's take the arc sine of 0 as 0, right? So pi over 2 minus 0 is going to be pi over 2. So that's the evaluation of the left hand side of the integration. I mean, this is the evaluation of the left integration. So yeah, so now we have to evaluate the right integration and equal the result to pi over 2. So let's focus on that. So let me get rid of some of the materials we went over. So I open up some space to write the remaining of the process. So yeah, let's use the black. So I'm in the right hand side, if you're gonna use U-substitution. So what I'm gonna do, I'm gonna say a minus s squared, a squared minus s squared is equal to u, and I'm going to take a derivative of u to respect to x, which is going to be negative 2x dx, all right? And so yeah, we're going to substitute this information in the right integration. So I have integration of negative 2x. So basically the negative 2x dx. So we forgot to do something. 1 second, please. So we forgot to divide both sides by negative 2, right? So you end up with x dx equal negative du over 2. And as you can see, we have x dx on the right integration. So I'm going to substitute that inside. So I end up with 1 over a square root of u, right? And you have negative 1.5 is going to be, we're going to put it outside, and you have a du here, right? So this simple integration, 1 over a square root of u is simply u to the power of negative 1.5. And then when we use the integration, the general form of integration, that is going to be u over 1.5, and then we have a reciprocal of the denominator, which is going to be 2, right? It's going to be 1.5 at the bottom, and then it goes up, becomes 2, and then we have a negative 1.5 outside. So this simply, we can get rid of this 2 with this 2, so you end up with negative square root of u. And let's open up some space. We need more space here, so let's get rid of these. All right, so yeah, so the evaluation of negative square root of u simply is going to be negative square root of a squared minus x squared, right? We already set up u value before, so we're going to use it in our advantage. So that's the integration we got for right hand side, but we need to take it with respect to the interval. So in this case is going to be negative square root of a squared minus s squared, and then we have a through 0. And when I substitute a here, I end up with negative square root of a squared. And then if you put 0, if you put a here, it end up with 0. And then if I put negative here on the right, on the second term, so so this becomes so let me get rid of this part here. So let me show you. This one becomes negative square root of 0, and then minus this one, right, becomes plus a square root of a square. And then this negative square root of 0 is simply 0, right? And then a square root of a square here is going to be the absolute value. Well, not the absolute value, but we are not trying to to make it positive. It means that we have a set of two solutions. So as you remember earlier, we got pi over 2. So this was equal to pi over 2. Remember from the left hand side of the integration. And then a is going to be plus minus pi over 2. That is our final answer. I hope you enjoyed this video. If you have any questions, please leave me with some comments. I greatly appreciate that. And looking forward with you with another episode of Dustin's Fun Math with more interesting math problems. Have a wonderful day and see you soon. Thank you. Bye-bye.